let's try another equation that's going to be a little harder, but you can still use all the same steps in order to do it. Okay, starting off with nitrogen. Okay, so in this equation, I have nitrogen gas added to water makes ammonia and oxygen. If you've ever used ammonia before, it's a cleaner and it's kind of nasty. You can make it by adding nitrogen gas to water, actually. In this equation, it can be balanced, but it isn't right now. Let's go ahead and see how unbalanced it is. I'm going to start from left to right. Nitrogen, hydrogen, oxygen. Okay, now I could look, it's the same order over here too, but I'm just going to write the same elements on this side. They always have to be the same. So it's whatever you start off with, you have to end with. Okay, now I have to count. There are 2 nitrogen atoms, there are 2 hydrogen atoms, and there's 1 oxygen atom. Now, on this side, I have 1 nitrogen atom, 3 hydrogen atoms, and 2 oxygen atoms. Okay, first step, let's just start up at the top. Let's start with nitrogen. Let's balance the nitrogen on the right by putting a 2 in front. Okay, that's balanced. Now remember, I want to update the hydrogen as well. So 2 times 3, not 2 plus 3, but 2 times 3 is 6. Okay, make sure you do that step correctly, because if you add these together, you're going to get a different number, and then the whole thing will go wrong. So these are very tricky. They're pretty simple in principle, but they're very tricky because if you go wrong in one place, the whole thing will go wrong. And sometimes you won't be able to balance it at all, and it'll get really frustrating. So do make sure you practice and go through these steps and double check your work. So now I've got 6 and 2. Okay, how do I make 6 and 2 equal each other? Well, I'll put a 3 right here. Okay, now I've got 6, but 3 and remember there's a little 1 here for the oxygen. 3 times 1 is, now it's going to be 3. Now there's a bit of a problem. So I've balanced the hydrogens, and all I need to do is the oxygens. It looks like I'm home free because this one's all on its own again. However, how can I make 3 and 2 ever equal each other if I can't make the oxygen split into a number that's going to equal 3? If I think about it, remember I have to use whole numbers. How can I make a number that equals 3? I can't, right? I could do 2, but then I would have 4. And then what do? I have to increase this one, and that gets confusing. And the answer is yes, that is what you actually have to do. But there's another way around it that you might like instead, and I think works for most people's brains. It's easier to do, and just bear with me. I'm going to break one of the rules. I'm actually going to multiply this by a decimal. And the way that I do that, I just think what decimal is going to, what fraction of a number is going to make 2 equal 3? Well, 1.5 is, when I multiply it by 2, is 3. So 1.5 times 2 is 3. And look at that. It's balanced. Except not, right? Because I can't have half a molecule, right? I can't have 0.5 of a molecule. That doesn't exist. So this is true in sort of in practice, but it's not true theoretically. It doesn't work it's not going to actually work for in real life. So what I do is I want to take care of that fraction, and what I'll do is a math trick. I'm going to multiply the whole thing by 2. I know if I multiply 1.5 by 2, I'm going to get 3, and that's a whole number, and that's fine. So I'm going to multiply it by the smallest number I can think of. 1 doesn't work. So how about 2? I'm going to multiply it by the smallest whole number I can think of and get that number to equal a whole number. So let's rewrite the equation with these new numbers. Though I multiplied this by 2, I actually have to do that to every single coefficient. So let's try that. 2 and 2. 2 times 3 is 6. 2 times 2 is 4. And 2 times 1.5 is 3. Now, that kind of looks a little crazy to go in that order, but if I didn't do that, I would have had to keep going back and I would have had to adjust a bunch of different stuff all at the same time, because this one molecule actually needed to have a 3 in front of it, and it's just difficult to know what order to go in because you never know where the problem is really going to happen. But this method takes care of that problem by just forcing the equation to balance, and then you can find a way to make everything a whole number later. So let's just double check that did work, okay? Let's put our letters down again. And let's count. 2 times 2 is 4 hydrogens. 6 times 2 is 12 hydrogens. 6 times 1 is 6 oxygens. 4 times 1 is 4. 4 times 3 is 12. And 3 times 2 is 6. And that makes sense, right? Because I balanced it earlier, and then I just increased its value of everything in there by 2. And so I just doubled all the numbers. So this is a really good and simple way of balancing difficult equations using that multiply it by a big number in the front. Okay, so if you follow those 5 steps, you will be able to solve any equation I throw at you, so long as you keep to those 5 steps and you're very careful about how you do your math and copying, okay? So stick with that, and I think you'll be fine. I hope that was helpful.